Hello, everyone, and welcome to another episode of 2D Twin Stick Top Down Shooter. My name is Casanis. Guys, in the last episode, we covered enemy aggro, and this is kind of bringing us towards the end of what I need to teach my students, so it's kind of bringing us towards the end of this particular series. There is one more idea that I'd like to cover before we call it quits, and that is the idea of object pooling. All right, let's get started. Okay, guys, so as I've mentioned, we're going to be examining something called object pooling. And what I've done here is I've created a simple side project just so you guys can see just the pooling itself. It's going to change depending on the type of game you're making or the game that you have or the enemies you have and exactly what you want to happen. So I've simplified this so that we can take a look at the ideas associated with object pooling as a separate project as opposed to something that I've done internally to the one that I'm already creating. So object pooling, what does it do? If we have a circumstance like we've got a game like Brotato, the 2D top-down shooters that we're kind of building here are like Brotato, or they're like a Vampire Survivor or something like that. You have opportunities where there are a lot of a lot of enemies that are being generated at one time. And each time that you go through and generate or instantiate a lot of mobs through a spawner or something like this, the game will have this slow chugging that'll occur within it if you've instantiated too many creatures, especially if we're using things like A star. So as we instantiate a new mob into the game, we're going to have to later on say, okay, find the player, set up your pathing to that player, start moving, and go after the player. And if we're doing this with 20 enemies at the same time, this can cause a lag spike. So we're trying to avoid a lag spike by, instead of instantiating something, having our mobs and our enemies already set up so that they are automatically in the game. There's no instantiation time. There's no lag that occurs because of the instantiation that we're trying to do. And we do this by creating a number of the objects. And in my case, I've got them right here. These are the objects we're going to instantiate. Well, not instantiate. These are the objects we're going to use in our game. I've built a number of these objects and I place them in the scene somewhere outside in my area that I'm calling the object pool. So, and I'm not calling it that. Everyone calls it that. So I've got these objects that are inside of this object pool. And what I'm going to do is whenever I need one of these objects, it's going to go into the pool, pull it out, and add it into the game itself. So there's no instantiation that occurs. These objects already exist. They are loaded whenever we first load the game. So that initial loading, that initial lag that occurs as everything is loading into the game occurs at the beginning as opposed to every single time you instantiate a new mob. That lag that occurs during the first loading is fully acceptable. Players accept this fact that, they watch their little loading screen, everything's happening, and then boom, the game starts and they move on from there. So this front ends that lag that occurs. Let's take a look at exactly what I've done here. In my case, I've really simplified it. So I've stripped away everything else in this game. There's nothing else here right now besides this object pool. And basically, I have these colored circles. And these colored circles are representing the enemies or mobs or whatever you want to call them that I'm going to be bringing into the game that are going to be chasing the player around. And I've placed more of these objects here than I think is necessary. In this particular example of the object pool, I've kept things really, really simple. We're looking at really, really simple concept of what an object pool could be. And I'll point out areas where you probably need to improve upon this idea as I'm going forward. But what we have in here is we have these spawn objects, and these spawn objects are really rather simplistic. They are placed in the scene off to the side here. They are a transform node, a sprite renderer, obviously to make them show up here. And we've got a rigid body, because what I want to happen is as they are brought in, they start to move, and then they're killed off, and then they return to this object pool. That's the entire idea. I need it here at the spawner. It gets brought in from here, dropped off on the spawner. It starts to do whatever it is going to do. When it dies, it returns to the original position in the object pool. So in order to do that, I've got myself this spawn object controller, and the spawn object controller is basically just to do exactly what I just said there. So let me just drag it over so you guys can see it. Okay, there we go. So the spawn object controller is made up of a number of variables here at the top. Can move. So As I mentioned, when I bring the object in, I want to start moving right away. If it's not in the game, can move is equal to false. If it is in the game, then can move is equal to true. I'm using that as a check to see if an object should be brought into the game or not. This is one of the areas that you should probably improve upon. When we take a look at how I'm doing my object pool, I simply have an array of those objects. That array of objects goes through and finds the first one that's not moving or that can move is false, and it brings that object into the game. I would really recommend, instead of doing this with an array, doing it with a couple of lists where you have a list of objects that are in the game and a list of objects that are not in the game. And as you pull an object out of the list of objects that are not in the game and they get added to the objects that are in the game. And it kind of breaks it up into two different parts. And then whenever an object is removed from the game, it gets taken out of the in-game and moved into the other list. That's a cleaner way of doing what I've done here. In my case, I kept everything super simple just to explain the ideas. So can move is when it's in the game will be true and it'll be moving about, and whenever it's not in the game, can move will be false. This vector move direction is simply the direction that the object's going to be moving in. Below that, we have a reference to the object's rigid body, so we can make it move. Below this is a vector 3 called original position. And when the game first starts, as I mentioned, we have a pool of objects that are somewhere outside of the gameplay area. What we're going to do is we're going to record the position that that object was in originally, and we'll return it back to that same position whenever we are done using it. Below this, we have alive time and return time. Both of these are simply values that we're going to check to kill this object off. You wouldn't do this unless you wanted to for some reason. But normally, what you'd do is you'd bring an enemy in. The enemy would be in the game until it was destroyed by the player, or it was had to despawn or whatever. This is representing that idea. So I'm using a live time and return time just to set it up so that these objects die off and then they are put back in the pool. That's all that's being used for. That would be replaced with whatever tool you're going to use to destroy your mobs as they exit the game. Okay, below this we've got our awake function, and we've moved this out of the start. So this is happening immediately. Immediately upon the start, every single one of these objects records its current location. So it looks at its own transform position and records that in original position. That way, we can always return the transform back to original position when we're done with it. I've also, in this case, calculated a move direction here in the awake. So when these objects are instantiated, they just will begin moving in the same direction each time. So each time you run it, it'll be randomized, but every time that object is pulled into the game, it'll move in the same direction. And alive time is how long this object will stay alive before we return it. Again, it's just a random range that's occurring here. Inside of our start, we look for our rigid body, and that way we can adjust its velocity later on. Now, below here within the update, what we do is we do a check for can move. And if can move is true on this object, then we start it moving in that velocity. I've done this in update, and again, this is not the right place to do it. I've done this really quick and dirty just as an example for you guys. This is not the way you do it. Obviously, you don't have to keep resetting the velocity once it's set. In this particular case, all I've done is if can move is true, that means this object is in game and I want it to start moving in the direction. This is super inefficient. It's not how you would do it. It's just for this example. Also within the update is a check to see if this thing has been alive for long enough, and then we're going to kill it off. If the time of the game is beyond the return time, then we're going to return this object to its original position. And we're going to set the can move equal to false. So down here, set can move false, so it's no longer in the game. And we set its transform position back to its original position, so it gets moved outside and into the pool. We also have this public call to set can move to true. When set can move is true, what we're going to be doing is exactly as it says, set the can move to true. That means it's in the game. And we are setting our return time, which we're using right here. We're setting our return time equal to the current time of the game plus the time that the object should be alive. And again, none of this is super efficient, but it does what it needs to do for this particular example. Okay, so let's move this out of the way. Okay, we have a few other objects inside of this project that we should take a look at. The object pool right here. The object pool itself is simply a list of the objects that we want to be in the pool. That's it. If we take a look here, we have object pool controller. I guess I should drag this back. Let's take a look at Object Pool Controller. The Object Pool Controller is, as I've said, simply a list of the objects that are in the pool. That's it. And I've got them as set as game objects here. I know what they all are, so if I needed to, I could have specified something very particular. I don't need to. In this particular case, we're specifying game objects, so it could be anything. What we are doing here is we've got ourselves this public, and it's going to return a game object called get object from pool. And get object from pool simply goes in and looks for the first object with can move equal to false. So if we take a look here, we are going through a for loop through all of the objects in the pool. We are taking a look at that object. We are looking for its spawn controller, the one that we just took a look at, that right here, our spawn object controller. We are checking to see if can move is equal to is false. So if can move is false, that means this object is not in the game. We then set can move equal to true, and we return that object to our spawner. All right, so it's calling this as our spawner. If there are no objects in the pool, it returns null. That means there's nothing available. Now, again, this is an area where we probably should consider an improvement. I have produced, I don't know, let me see. I have produced 10 items here, 10 objects that we might be able to call in through the pool, from the pool. And if we overrun that array, if we've gone past that and there's no objects that are available in the pool, then we just say you can't spawn anything. It returns null, and that's the end of it. What you really should be doing in this situation is if there are no objects left in the pool, then you may wish to instantiate one of these objects and add it to the pool. So your pool, in my case, my pool is an array. You can see here that I've got it as an array. Really, the pool should be a list so that we can continuously grow that pool. We can add in objects when we need to add in the objects of available objects. What that is going to do in this particular case is if nothing else can spawn, if I overrun my array, nothing will spawn. If you've done this properly, what you would do instead is set it up so that if there are no objects in the pool that can't move, and again, can move is a ridiculous way of checking to see what's in this array that should be added in. You really should, as I mentioned previously, have two lists, one of the ones that are available, one of the ones that are in the game, and you keep pulling from the ones that are available as opposed to using an array. But in this particular case, if there was nothing that was available, what I should do here is instantiate a brand new object. I should have another function here that's called add to pool, and then I should instantiate somewhere in the vicinity of where the pool is currently located. So I instantiate it over there, I make it available, and I go through and like add everything I need to. Obviously, everything's been added in for the particular object. So it's got an original position, everything. We add it into the pool, we pull that out, and then when it's dead, we just add it back in. So it's a growing object. That's what should be done here. I haven't done it. I've kept it really simple just for explanation's sake. Okay, that's all that happens in the pool. That's all that's happening here is it's tracking, which object is next available. So the only other object that we've got in here is our spawner right here. So let's take a look at the spawner. Oftentimes, when you see a spawner, you might consider it to be something that spawns an object, instantiates an object. That's where the enemies are coming from. And that's exactly what this is doing as well. However, rather than instantiating the object, we are simply pulling something out of the pool. So I've got a number of spawners here set up, and each of these spawners will do the same thing. The spawner itself consists simply of its transform node, so where it's located, as well as the spawner controller. One more time, let me drag this back. I don't know why I keep dragging it away. If we take a look at the spawner controller, it is simply going through and spawning the objects, as in moving it from the pool into this location. So let's take a look at what I've got in here. We've got the spawn rate, so how often this thing is going to spawn, how quickly it's going to spawn, when the next spawn is going to occur. We have a public reference to our object pool, so it knows where it's getting those objects from. And we have a reference to the object that's actually being spawned. So let's go down here and take a look at our start. In our start, we're basically setting up the clock. It's starting the timer. The next spawn, when this can occur, is at current time.time. That's when the next spawn will occur. So it's going to spawn something immediately upon the start of this game because time.time will be 0 at that time. And then afterwards, we're going to update time.time we're going to update the next spawn accordingly based on the spawn rate up here. Okay, so in the update, and again, this is really simple, guys. In the update itself, all we're doing is taking a look to see if enough time has passed that we should spawn something. If it is, it's going to, well, we're printing spawning. If it is, then we are going into the object pool. We are pulling something from the object pool like we saw. So we're finding that first one that's not moving. After that, if there's nothing there, then we go in and we are, if it's not null, then we just simply move the object from the object pool because we've got a reference to it right here. We move the object from the object pool's location into the transforms location of the spawner, and then from there we reset our spawn time. The spawn object itself takes care of killing itself off after a certain amount of time. We already saw that. And that's it. That's the idea behind the spawn pool or the object pool. It's really rather simplistic and it can save a ton of loading time. Let's just watch it in action here so you can see how it's working. So let's just watch what happens when I hit play. So you can see that the objects are being pulled out of the object pool over here. They're being yanked out and placed onto the spawner locations. You can see that I'm never overrunning this. I've added enough spawn objects that I'm never kind of overriding or overrunning the objects I have here. In fact, it looks like I'm only using these 4 based on the timing that I've got associated with this object because of the randomization of it. I'm only ever hitting these 4. Let me stop it and start it again and see if we can pull more of them out. It'll depend on that spawn time. There we go. We're pulling a little extras out there. So what's happening here is the objects are being pulled out. They're being moved from this location onto a spawner, whichever spawner is making the call. They are being allowed to start moving. And that's it. The objects themselves kill themselves off, and then they return to the pool. And you can see there's absolutely no load time associated with this because all the objects are currently in the scene. So there's no instantiation that has to occur. All right, guys, that's it. That's how easy an object pool works. The one I've got here is really bare bones. What I went over with you is really bare bones. Obviously, we should improve the operation of this utilizing several different lists, as I mentioned before. Do a better check to make sure that we're not pulling things out. Make sure that we never have a null as an option so that we're always pulling things out of here so we always have objects that are available in our pool. These things can be added to this idea, but in its simplest form, this is an object pool. And I think it can be used not only for enemies, but anything at all that you might need. Bullets, if you want to, if you've got a bullet hell going on and you want to make sure you're not instantiating 5 billion bullets, you could have bullets off to the side and pull them out of the object pool and send them off in the direction you need to do. All of that can be done with object pools. Anytime that you have a large number of objects that need to be instantiated and you don't want to have that instantiation time occur during the middle of gameplay, you can use an object pool. All right, guys, I hope that was helpful. I think this is going to be the last episode of this particular series. I don't know if there's anything else that my students need to pick up. The rest of it is kind of up to them. They are all off and they're making themselves awesome games. Those games are going to be available on our itch channel, which I will link down below in this episode. They'll be available later on in our itch channel, or on our itch channel, I should say. So I hope you take a chance and check them out. All right, guys. I hope that was enjoyable. If it was, let me know down below with a thumbs up. If it wasn't helpful, just let me know. This is the last of this particular series, I think. I will add in other things if students are asking me questions, but everything else is kind of up to them. They're each making games that are wrapped around different mechanics. So I've kind of covered the base mechanics that they need, and that's it. All right, guys, so thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.